So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own master coder this side. So today's problem is indexes of subarray sum, right? The problem says that you have an array. This is your array, and this is your target sum. Target sum, right? Now you have to find a subarray, or to be specific, you have to find the first subarray from this given array, such that the sum of the subarray is equals to sum. Right? The constraints given to you are the target is always positive, right? And the numbers, the array elements are also positive. That is ARRI is always greater than equals to 0 for all I belonging to 0 to n minus 1, right? And also in the answer, suppose for the given case, the answer you can see 3, 4, 5, 6. 3, 4, 5, 6 is giving me a perfect answer, right? 3 plus 4 gives me 7, plus 5 gives me 12, plus 6 gives me 18, which is the required target. So indexes are 0, 1, 2, 3, 4, 5. That means 2 to 5. But you have to return 3 to 6. That is one base indexing you have to return. You have to return one base indexing. Return one based indexing. So these were all the points related to this particular question. How will you solve it? How will you solve it? Very easy, guys. Very easy. First, we will solve the brute force. Brute force. Whenever there is a question of subarray and you have to solve it brute force wise, you know how to do that. You will use one loop I going from 0 to n minus 1. Inside it, use another loop j going from I to n minus 1. Right? Use another loop inside it. K going from I to j. Right? Initialize the sum equals to 0 here. Sum plus equals to array of k. And if after this loop the sum gets calculated and if sum equals to target, okay, if sum equals to target, return what do we done? Now our starting from of the array was I and ending of the array was j. This loop was just for sum. So return one base index, that is I plus 1 till j plus 1. Right? Both the loops will finish. What is the time complexity? N from this side, n from this side, n from this side. That is O of n cube, and O of one space is used. Right? These are the complexities related to the brute force solution. Right? Now, every one of us knows that we can remove this loop. How? Let us see. So, efficient solution. Efficient. For I going from 0 to n minus 1. For j going from 0 to n minus 1. Not 0, sorry. It will be I plus 1 to n, I from n minus 1. I to n minus 1, sorry. Yeah. Now, what will you do? You will say sum equal to 0 here itself. Then sum plus equals to array of j. Now after this, if subarray sum is if sum equal to target, if sum equal to target, then it also means that we have found a subarray. Then return I plus 1 j plus 1, right? The two loops get finished. Otherwise, if not found any array, return minus 1 as said in the question, right? Now n from this side, n from this side, so O of n square and O of one space. These are the complexities related to this. These are the complexities of this. But we have a bigger plan. What? To write the optimized version, right? So what were the elements? The elements are simple: 1, 2, 3, 4, 5, 6, 7, and I wanted a target of 8, 18, sorry, right? What can I do? Subarray, right? See, usually when subarray and sum are related, you have two approaches. First is sliding window, subarray plus sum, right? And second is using a map. Unless and until something very different is asked, these two approaches will do your work. These two approaches will do your work. Now, because it is mentioned that array of I is greater than 0, we can use sliding window. We can use sliding window. Why? Let me tell you. Let me say that my start is lying here, my end is lying here, and my current sum is equals to 0. Right? What does sum indicate? Sum indicate sum between elements from start till end, inclusive of all of both of them, right? Okay. Right now, what has happened? The sum has not included one, so change your value to one and move your e, right? Because that means sum start to index, start to end. That is one element is here, one. The sum is one. Now you see that sum one is not exceeding target, right? It is not exceeding target. Okay, so add to it also it. One plus two gives me three. This was okay. Now E comes here. Again, 3 is not exceeding 18. That means add. 3 not exceeding 18. Add 3 plus 3 gives me 6. Exceeding, not exceeding. So 6 plus 4 gives me 10. Not exceeding. 10 plus 5 gives me 15. Not exceeding. 15 plus 6 gives me 21. Exceeding. So as soon as it is exceeding, 21 is greater than 18, right? 21 is greater than 18. That means something has to be removed, some positive element has to be removed from current subarray. What is current subarray? Elements included between S and E, right? Now, why positive? Because we know that to decrease the sum, we have to decrease something positive. If we will decrease something negative, if we will remove something negative element, it will not work. By the grace of God, the equation says that all the elements are positive. All the elements are positive. So work is actually reduced. Now, because all the elements are positive, I can actually use the sliding window. What I'm trying to say, if suppose these were the elements, minus 1, minus 2, 3, 4, 5, 6, 7, right? Minus 1, minus 2, 3, 4, 5, 6, 7. And this window gives me an answer of greater than 18. This window gives me a sum of greater than 18, right? And now if I would have incremented start to remove these elements from our window, what would have happened? Instead of decreasing our sum, I would have tend to increase it, because if I will remove minus 1 and minus 2, the sum will increase by 3. That will not work, right? So that is why we use a map in that cases. But for sliding window, we can simply use removing elements, because we know all the elements are positive. We know all the elements are positive, so we can simply remove them, right? Okay, so start removing. 21 is the current sum, right? A start is lying here. Remove it. So 21 minus 1, right? Start comes here. It becomes 20. Let me write it here, right? Again, it is again greater. 22, 20 minus 2, it becomes 18. Start comes here. Now if you see, now if you see 18, 18. As soon as 18 comes, we say, okay, let us stop where the start and end are, right? Okay. Target equal to 18, right? Target equal to 18. That means our work is done. We found an array, we found a subarray, we found a configuration of S and E, so the target equal to 18. Let me find the indexes. So indexes are 0, 1, 2, 3, 4, 5, 6. In terms of one base indexing, so 1, 2, 3, 4, 5, 6, 7. My E is lying at 6, my S is lying at 3. So my answer will be 3 to 6, right? And that's all, right? So what was our algorithm? Our algorithm works something like this: S equals to 0, E equal to 0, and sum equal to 0, right? These were the three elements we initialized. Now while my end is less than n, first increment sum plus equals to array of e. Now while my sum is greater than target, what do? Sum minus equals to array of start and start plus plus, right? This was happening. We were incrementing start and decrementing our sum until sum was greater than target. After this, check if sum equal to target, found the answer, simply return. What do we return? Now S and E are lying at zero base indexing. So S plus 1, E plus 1 to convert them into one base indexing. Right? Loop ends. Oh, before the loop ends, N plus plus for the next element. Return minus 1. That is, from the whole array, we were not able to find any subarray which was returning this sum. Right? So I hope I am clear. Time complexity here is O of n, guys, and space complexity is O of 1. Right? Because we are doing only one traversal, no other explanation needed. Let us try to move to the code now. So here is the coding section, guys. So first thing we have to do is write the size of the array. Int n equals to array dot size. Second thing we have to do is subscribe to the channel, right? I hope you all have done that. So moving on. So int start equals, let us say start as s only, is equals to 0, end equal to 0, sum equal to 0. While my end is less than n, what do? We first increment the sum plus equals to arr e. Now while my sum is greater than target, sum minus equals to arr s and s plus plus. Now if sum equal to target, then our work is done. Return s plus 1 e plus 1 and return minus 1 if nothing works. Also I forgot here also e plus plus for the next iteration. Try to compile and run it. Working fine for the sample test case. I hope it will work fine for the submit as well. Running and getting accepted. So thank you for watching. Hope you liked it, and please make sure to like and subscribe to the channel. Thank you. Have a nice day.